Hi guys, welcome to lesson of ordinary differential equations. So previously we discussed some exact differential equations. So now we are going to discuss some equations that are actually not exact, but we can make them exact by using some formulations, right? So the topic is non-exact, or we can call it equations that are reducible to exact equations, right? Reducible to exact equations. So before embarking into the problems, first of all, we will use the general idea of exact equations. We said that an equation is exact if dawa m over dawa y is equals to dawa n over dawa x. But what if this is not the case? If they are not equal, so what we need to do? So the first case, that is case one, which is going to be the topic of our discussion today, says that if this happens, that dawa m over dawa y is not equals to dawa n over dawa x, then try dawa m over dawa y minus dawa n over dawa x over n and check whether it is a function of x only, function of x only, right? This is important point. If it is a function of x only, this equation gives a function of x only, then the integrating factor that will make our equation exact is equals to exponential to the power integral the function of x dx. This function of x represents this one. If this is a function of x alone, then we can use this integral factor, and then we can multiply this factor with the equation that is m dx plus n dy is equals to 0. So we can multiply this integrating factor, that is exponential to the power f of x dx, and then the equation will become exact, right? So let's take an example and we'll see that how this method works. So we have a question that 2x ln x minus xy times dy plus 2y dx is equals to 0, right? So this is the problem. Now we will check, this is n. Remember, anything with dy is n and anything with dx is m. So this is m and this is n, right? So dawa m over dawa y is equals to 2, and dawa n over dawa x is equals to, this is 2x ln x, which means that we need to differentiate this using the product rule. All right, so this will be twice of x over x plus ln x, then minus for this one xy, it will be y. So we can see that here dawa m over dawa y is equals to 2, and dawa n over dawa x is equals to 2 plus 2 ln x minus y, and which are not equal. Therefore, this equation isn't exact, right? This isn't an exact equation. So now we need to check whether the formula that we already discussed, that dawa m over dawa y minus dawa n over dawa x over n gives a function of x or not, right? So apply this rule, dawa m over dawa y is 2 minus dawa n over dawa x is this function. So we can write 2 minus 2 ln x plus y divided by n, which is 2xy. All right. So, sorry, our n in this case is 2x ln x minus xy. So it's 2x ln x, 2x ln x minus xy. Now this is equals to 2 cancels, negative 2 ln x, positive y, divided by x is common, so we can take it outside. We're left with 2 ln x minus y, right? So this is the same as this, so we can cancel and we will left with 1 over x. So we can see that this function is the function of x only, that is 1 over x. So we can easily find the integrating factor, that is equals to e to the power f of x dx, right? So the function in this case is 1 over x, so 1 over x dx, which means that this is e to the power ln x. Therefore, this cancels out and we will left with x. So the integrating factor is x here. Now we will multiply this equation, that is the initial equation, by x. So this will be one thing. I think so there's a mistake here. That is it should be negative. This is 2 ln x, and yes, there should be negative 1 over x, because this is negative 2 ln x plus y and this is 2 ln x minus y, and to make it compatible with the denominator I should take negative 1 is common outside, then it will be negative 1 over x, so it's negative 1 over x, and here also it's negative 1 over x, so it will be x to the power negative 1, because it's negative, so we can write it as sorry, not actually like this. Yes, it's 1 over x. Yes, it's fine, it's 1 over x, right? So this is the integrating factor in this case, so we can multiply the equation by 1 over x. So let's do that. 1 over x times 2x ln x minus xy dy plus 2y over x dx is equals to 0. Now check and also multiply by 1 over x here. Sorry, we already multiplied. Doing something messy. So now we can check whether, first of all, simplify this problem. So it will be 2 ln x minus y dy. And now we can check whether this is exact equation or not. So let's check again. Now m in this case is this one and n is this one. So dawa m over dawa y is equals to 2 over x, and dawa n over dawa x will be equals to 2 over x, right? So now this equation is exact because both the partials are equal, and we can now simply solve the integrals for these functions. So the integral of this function will be integral to ln x minus y times dy plus 2y over x times dx is equals to 0, where we already said that for any function of x will be 0 here, and any y will be constant here, right? So this will be 0 because it's a function of x, and we can integrate this negative y, which will make it negative y squared over 2, and then plus 2y is constant, and for 1 over x the integral will be ln x is equals to c. So now we can write it in this way: y squared over 2 minus 2y ln x is equals to c. So that's the answer for the given equation, and you can verify these answers by again taking the derivatives, right? and getting back the equation that we already solved. So now let's take one more problem for more practice. Uh, let's take one problem from the book, that is x sec squared y minus x squared cosine y is with dy that is equals to tangent y minus 3x to the power 4 multiplied by dx, right? So now, first of all, what we need to do is we need to arrange the equation accordingly, make compatible with the original form. So it will be dx minus x sec squared y minus x squared cosine y dy is equals to 0. Now check whether dawa m over dawa y is equals to what and dawa n over dawa x is equals to what, right? So dawa m over dawa y, the integral of tangent y will be, so integral of tangent y is simply ln sec y, and for 3x4 it will be 0, and for this one it will be negative sec squared y minus 2x cosine y. All right, so now we can check that whether dawa m over dawa y minus dawa n over dawa x divided by n is function of x or not. So dawa m over dawa y is ln sec y minus dawa n over dawa x is negative sec square y, which means, and this is positive, sorry, because of this negative, and this is this will be positive sec squared y, and then this will be negative 2x cosine y divided by n. And what is n here? N is x sec squared y minus x squared cosine y. Right. So there's a mistake here. I mistakenly take the integral of tangent y, but we need to take the derivative. Unfortunately, I did the mistake there. So it will be sec squared y, right? Now it will be equals to 2 sec squared y minus 2x cosine y divided by x sec squared y minus x squared cosine y. This is equals to, we can take 2 as common, so it's sec squared y minus x cosine y, and in the denominator we can take x as common, so it will be sec squared y minus x cosine y. So we can see that this cancels out and we will left with 2 over x. So we have the function of x only. So we can find the integrating factor easily. Integrating factor will be equals to e to the power 2 over x dx, which means that it will be e to the power 2 ln x, which means that this is equals to x squared. So we can multiply this equation by x squared and we will get the desired equation that will be exact equation, right? So it's x squared times tangent y minus 3x to the power 4 dx minus x squared times x into sec squared y minus x squared cosine y, and dy is equals to 0. Now check whether this is exact or not. This is m, this is n. So dawa m over dawa y, which means that we will get x squared sec squared y and dawa uh, n over dawa x. Uh, so what we will get here is dawa n over dawa x Uh, there is a minor mistake again because here it's negative sign, so it will be negative and this will be positive, so we will get negative 2 over x, so it will be negative 2 over x, so negative 2, which means x to the power negative 2, which means this is 1 over x squared, not x squared. So this is 1 over x squared and this is 1 over x squared. Now we can check whether this, first of all, make some simplifications in the equations to make it easier. Otherwise, then it will create some confusion. Therefore, write it in this way: tangent y over x squared minus 3x squared dx minus sec squared y over x, and then minus cosine y dy. Now it's fine. So dawa m over dawa y will be equals to sec squared y over x squared, and dawa n over dawa x will be equals to negative times sec squared y over negative x squared. So now we can see that they are equal. Dawa m over dawa y is equals to dawa n over dawa x, which is equals to positive sec squared y over x squared. So the equation is now exact and we can solve this equation. We can integrate this equation simply, this one, right, this equation. So this is tangent y over x squared minus 3x squared dx. So this is tangent y over x squared minus 3x squared dx integral, then negative, and on this side we have sec squared y over x minus cosine y, sec squared y over x minus cosine y dy. So again, any function of x will be 0, will make the whole function 0, and y will be treated as constant here. And now we can integrate this function. So tangent y will be treated as constant, so we will get negative 1 over x minus x cube, and then this one is 0 because of this x, and plus sine y is equals to c. So the final answer is sine y minus tangent y 1 over x times tangent y minus x cube is equals to c, and that's what we need, and it's the final answer. So hope you guys understand this lesson, how to solve these, how to make these non-exact equations exact by in using the substitution, by using the integrating factors, and by using the formula and looking whether the formula is giving a function of x independently or not. So remember that when we will be working on some other problems, on some other cases, we will see that how to formulate if there is not an independent function of x, and we can also get a function independent, only independent, there is a function that is a function of y, right? Only function of y. So how we will do that, and then we have some other cases, right? So that's all for the timing for this lesson, and we will talk about some other cases in the next videos. So stay tuned for that. That's all for the time being, and thanks for watching the lesson.